A quick view of Jupiter before I launch into the NGC, I believe it's the 1650 to 1699 series. Let me check that out. Yes, that is the case. And I definitely don't want to jump ahead or reproduce work I've already done. This may be one of the better views of Jupiter we've gotten through the 150 millimeter f4. I'm not going to use the aperture stop on this occasion. Jupiter is not quite anywhere, probably only about 25 degrees up. It's almost 6 o'clock on the 9th of February 2026. Let's do some zoomage and let's see where we start to see pixelation. So this, right, by the way, is a 450x view. Not bad. I don't think I have to change the focus at all. We're almost maybe making out the equatorial. No, we're basically, first, as we talked about in previous videos, we've got the two equatorial belts. We're getting hints of the temperate belts, north and south. When it starts to pop, we will see that central belt bisecting Jupiter's ample waistline. It's Monday night, the 9th of February 2026, and we're getting our first view of, what do you think this baby is? Why, of course, it's an open cluster. I got to make sure I get the value right. I believe it's NGC 1664. I'm going to cover some northerly studies first, as I have done in the past, simply because we've had some bad weather. NGC 1664 is an open cluster in Auriga, magnitude 7.6, 18 arc minutes in size. The brightest stars are magnitude 10.6. It's a class 3-1. I would assume the class 3 Roman numerals has to do with its distinctiveness, and the 1 has to do with the fact that many of the stars are very similar brightness. It's 3,900 light years distant, located at right ascension 4 hours, 51 minutes, 6 seconds, with a declination of plus 43 degrees, 40 minutes, and 30 seconds. I'm hoping we will get to hour 5 in the NGC 1650 to 1699 series. Let's see. Now here's something a little mysterious. I'm going to step through. I went inside, grabbed a cup of tea. We got 64 stacks with none ignored. That tells me how perfect the focus is. Now, here's the interesting thing about this. NGC 1675 is supposed to be a nothing burger in Taurus. Nothing. No information available. It's at right ascension 452.24 with a declination of plus 23 degrees, 54 minutes, and 30 seconds. Well, I'm looking around the screen, and unfortunately, we had a satellite passage right through what appears to be an edge-on galaxy. Now, I did remodel the scope to make sure that it centers up better. But I suspect there's an edge-on galaxy right about there. I cannot believe the satellite passed right over. Anyway, that's NGC 1675. One of the half dozen or so studies that I'm going to go capture up north before we start to lose ability to see things through the roof tries later on in the evening and in the 1700 series. Our next study, NGC 1707, has got two distinctions. I've been watching Orion proceed towards culmination for at least a month, maybe 2 months now, and it's finally getting close. NGC 1707 is the first NGC value that's associated with Orion, I do believe, at least in the northern part of the northern hemisphere. There's no information available. It's called simply a group of stars. Now, let's see, can we distinguish anything like... No, I don't see anything that distinguishes a group of stars here. We're at RA 458.20 with a declination of plus 8, 14, 18. And that's kind of another nothing word. Well, NGC 1746, there's certainly something right here. But it's supposed to be an open cluster in Taurus, magnitude 6.1, 42 arc minutes in size. So this is probably the entire open cluster here. Since this field of view at 30x is about 75 arc minutes. It's 1,400 light years distance, the class 3-1. So maybe that class 3 is have to do with how visible it is. I'm not sure. I'm going to have to look it up. 1,400 light years distance. The brightest stars are magnitude 8. There's a great deal of variety in it, so class 3 Roman numerals certainly seems like it has something to do with brightness disparities. RA is 50350 with a declination of plus 23 degrees, 46 minutes and 12 seconds. Well, if you look at this drop edge here, NGC 1758 is very close to the last study we had, although it's more advanced numerically in the NGC catalog. And I think I can look up exactly what our last study was. Our last study was NGC 1746. So now this should be this open cluster right here. Let me get you the data. Okay, NGC 1758 is an open cluster in Taurus, right across the border from Orion. This is probably the Orion study. It's to the west, but perhaps slightly more north in the center of this one, which is why it is in this one. Okay, hold on. This 1758 is more east, obviously, but this is more north. Good. Got it worked out. It's an open cluster in Taurus, 39 arc minutes in size. It's a class 4, Roman numeral 1. 2,500 light years distant, RA 50435 with a declination of plus 23 degrees, 47 minutes and 54 seconds. There are entries in the NGC catalog that do skip around in terms of right ascension, etc. So it's possible things are a little bit messed up. But this is the east, this is south, north, and west. And this was our earlier open cluster in Orion. Okay, we're now off to another open cluster. This one's in Riga, NGC 1778. I think they were still fighting the War of Independence in that year. Magnitude 7.7, 7 arc minutes in size, 25 stars. Brightest is magnitude 10.1. It's a class 3, 2. 4,800 light years distant. RA is 5 hours, 8 minutes, 4 seconds with a declination of plus 37 degrees, 1 minute and 24 seconds. All right. This is NGC 1798. It ordinarily would be out of bounds because it's at plus 47 degrees, 41 minutes, 30 seconds. But I wanted to get a sense of how much either light or blockage we were getting at 47 degrees, 41 minutes, 30 seconds north. Now I can see an open cluster right about there. It's in Riga, magnitude 10. So it's a very faint open cluster. The brightest stars are magnitude 13. Very interesting study, that is magnitude 13. It's a class 2, but it's quite distant. Class 1-1. That's weird because it's not easily distinguished. It's easily distinguished, but the stars are very faint in a very star-filled field. 14,900 light years distant is quite a ways off. We're at right ascension 5 hours, 11 minutes, 39 seconds with a declination of plus 47 degrees, 41 minutes and 30 seconds. Now I'm going to point out, I can spend a little time on these studies tonight because we have entered into the Milky Way's outer rim. And as a result, there's going to be less galaxies visible to the north. And most of them are going to be in the deep southern hemisphere. So let's see how many galaxies we actually turn up and other studies in the NGC 1650 to 1699 series, which should be the study for our evening. And that series is going to start at 6:30 p.m. And the sky is looking really good. And I do believe we just entered into sky time. Okay, our first study in the NGC 1650 to 1699 series is right smack dab behind the diffraction light from a power line. And I do believe the galaxy is located right there, well positioned on the screen. It's magnitude 14, quite large for a 14, 2.3 by 1.3 arc-minute elliptical, 486 million light years distant. And if that truly is the value, this galaxy is over 300 60,000 light years in diameter. That is huge for an elliptical. Massive. Billions of stars, no doubt. We're at right ascension 4 hours, 45 minutes, 11 seconds with a declination of minus 1552. 12. Too bad we're not getting a particularly good view. I will push it up. And I do believe that may be the core of our galaxy, although we saw something larger about there. Let me back it out again. What did I just do? All right, back it out again. And there, I do believe, is our galaxy right there. NGC 1653 is a galaxy in Eridanus. We skipped 1 and 2. Apparently, they were too far south. It's magnitude 12, 1.5 by 1.5 arc-minute elliptical. Let's look for this, sweetie. Is it up there? Oh, we do have to do some shifting. Maybe I'll do another modeling on this galaxy here. 1.5 by 1.5, 193 million light years distant with a right ascension of 445.47 and a declination of minus 223.33. So there's our view of NGC 1653. I do want to push the magnification up. I'm not sure that I want to go ahead and jump in right now because we've really shifted the scope to see this elliptical galaxy, but it sure looks like our candidate for 1653. Okay, NGC 1654 is pretty close to the last one, 53, I believe. Galaxy in Eridanus, magnitude 13.4. 0.8 by 0.8 arc-minute spiral for the lowercase a. Really not liking this centering. Maybe I'll reload the model. 0.8 by 0.8 arc-minutes, 201 million light years distant, RA 445.48 with a declination of minus 205.01. Okay, we're now on to NGC 1656. It's a galaxy in Eridanus, magnitude 14. Right there next to that bright star, 1.5 by 1 arc-minute. So it's got a bit of a oblateness presentation, as you can see. Spiral with lowercase a, 169 million light years distant, maybe 70,000 light years in diameter. Focus is really good tonight. Stars look good at 150x. And we are at right ascension 445.53 with a declination of minus 5 degrees, 8 minutes, and 12 seconds. Okay, now it's NGC 1657, a galaxy in Eridanus, magnitude 13.8, right in the middle of the field, 1.2 by 0.8 arc-minutes. Spiral with a bar, lowercase bc, not much of a core, so it's not this one, it's this one. We're at 4 hours, 191 million light years distant, so it's about 50,000 light years in diameter. RA is 446.07 with a declination of minus 2 degrees, 04 minutes, and 37 seconds. Pushing it up, 150x view, and gone. NGC 1659 is a galaxy in Eridanus. Magnitude 12.5, yep. 1.5 by 1.1 arc-minute. Looks like it has an annularity as far as I can tell, but it's not here in the data. Spiral with a bar, lowercase bc, 205 million light years distant. Lowercase bc means it's relatively immature, but it's got a bright core. And it typically also means it's got multiple spiral arms, so we could be confusing those multiple spiral arms. 205 million light years distant with a declination of a right ascension of 446.30 and a declination of minus 447.20. We got a little bit of a breakage in the spiralicity here, don't we? All right, we've now entered the Orion city limits for the very first NGC study. The other one was one that I had to skip to because it was further north on the border of Taurus. And I believe that was an open cluster. 1661 is a galaxy in Orion, magnitude 13.2. Getting pretty sharp focus tonight, good stable skies. 1.4 by 0.9 arc-minutes. S spiral lowercase bc, 397 million light years distant, means it's probably as large as Messier 31, 150, 160,000 light years in diameter. It's at right ascension 44707 with a declination of -2 degrees, 3 minutes and 16 seconds. NGC 1662 is one of possibly two open clusters. This one is in Orion. Magnitude 6.4, 20 stars, 20 arc minutes in size, 35 stars. The brightest is magnitude 8.3. It's class 1, Roman numeral 1, 2, which the 1 probably is how present it is in the field. I'm going to work with that from this point on until I get otherwise. 1,400 light years distant, RA is 448.27 with a declination of +10 degrees, 56 minutes and 12 seconds. NGC 1663 is another open cluster in Orion. And I did not get the data up when I punched the button. I got my gloves on, so it's very cold tonight. Open cluster Orion, 30 stars. It's a class 4-2, so draw your own conclusions about it. 2,300 light years distant, right ascension 449.21 with a declination of +13 degrees, 9 minutes and 0 seconds. Okay, we imaged this one earlier. It's that open cluster in, and I got to reset it a little bit. Hold on. Okay, we had some star streakage. This is NGC 1664. Now, I believe this is our open cluster. It's pretty far south, though. When I remodeled, something got messed up again. Open cluster Auriga, magnitude 7.6, 18 arc minutes in size, brightest stars 10.6. Yeah, they don't look that bright to me, folks. We're getting a little bit of reflected light. It's a class 3-1, pretty present in the field. 3,900 light years distant, RA 451.06, declination +43.40.30. We did image this one earlier, and we'll have a nice little comparo for that. NGC 1665 is a galaxy in Eridanus, magnitude 14. You can see it right there next to the E-zoomage. 1.8 by 1.1 arc minute, lenticular spiral, 121 million light years distant, probably about 75,000 light years in diameter. RA 448.17, declination -5, 25.39. Could have a frontier on it. Let's have a look. And it's got a neighbor. NGC 1666 is a galaxy in Eridanus. I think we can see it there. Magnitude 12.6 makes sense. 1.4 by 1.1 arc minute. Spiral with a bar, lenticular. That makes sense too. There's a bright galaxy further to the north, but very slightly east. We should be covering that one as well. 122 million light years distant, RA 448.32, declination -6.34.12. See if we can frame them both up and pause. As it turned out, that brighter galaxy was, in fact, NGC 1667. It's also NGC 1689. It's magnitude 12.1. 1.8 by 1.4 arc minute spiral with a bar and a lowercase c. It's at 204 million light years distant, and so it's probably a little bit larger. It's probably about 110,000 light years in diameter, larger than the Milky Way. RA 448.37, declination -6.19.12. Okay, we're delving a little deeper into Orion now for NGC 1670, a galaxy, magnitude 12.7, 2.1 by 1 arc minute. Pushing up the magnification on such a good night of transparency and stability. Lenticular spiral, 205 million light years distance, so probably about 130,000 light years in diameter. RA 449.42, declination -2, 45.38. Moving quickly now, NGC 1671 is a galaxy in Orion, magnitude 12.9, 1.1 by 0.9 arc minute, lenticular, 283 million light years distant, RA 449.33 with a declination of mere 15 minutes and 11 seconds to the north. NGC 1677 is a galaxy in Eridanus, magnitude 15, 1.1 by 0.4, should be a nice edge-on view. Lenticular, 124 million light years distant, RA 450.52, declination minus 453.33, pushing it and bailing. NGC 1678, I'm not getting the data for some reason, is obviously a galaxy, and it's an Orion, magnitude 13.2. It's got a friendly neighbor, 1.1 by 0.8 arc minute lenticular. As I said, 212 million light years distant. RA is 451.35 with a declination of minus 237.24. NGC 1681 is a galaxy in the river Eridanus. Magnitude 13.5, 1.3 by 1.2 arc minutes, spiral with a lowercase b, has a nice frontier to it, 123 million light years distant. RA 451.50 with a declination of minus 548.12. NGC 1682 is a galaxy in Orion. Magnitude 14, 0.8 by 0.8 lenticular, bright core, 195 million light years distant, RA 452.19, declination minus 306.20. It has a neighbor, and it also has a satellite passage. NGC 1684 is a galaxy in Orion. Magnitude 13, quite large, 2.9 by 1.9 arc minute, elliptical, 198 million light years distant. RA is 4 hours, 52 minutes, 31 seconds, declination minus 306.21. NGC 1685 is another galaxy in Orion, probably in the same group. Magnitude 14.5, 1.3 by 0.9 arc minutes, spiral with a bar, lowercase, and bar, lenticular A, 202 million light years distant, RA 452.34, declination minus 256.58. NGC 1686 is a galaxy in Eridanus, magnitude 14, 1.7 by 0.3 arc minutes, spiral with a lowercase bc, 254 million light years distant, about as large as Messier 31. Our ascension is 452.54 with a declination of minus 15.20.48. And no, we have yet to be in the paucity of galaxies. We're getting quite a few in the visible from plus 30, minus 30 to 45. So we haven't quite entered the district of the Milky Way galaxy as of yet. NGC 1690 is another one of those galaxies in Western Orion, magnitude 15, 1.1 by 0.4 arc minute, elliptical, 391 million light years distant, RA 454.19, declination plus 1 degree, 38 minutes, 25 seconds. Let's push it a little bit, and there we have it, plus a very bright star in the same field of view, and a fainter galaxy or two. Although this looks very peculiar here. Hold on a second. Yes, indeed, there is something creeping across the field right there. Brighter, dimmer over a 5-second interval. Possibly a spinning something that's brighter, more reflective in one angle, and dimmer on the other. It is passing through space, less likely the atmosphere. NGC 1691 is another galaxy in Orion, magnitude 12, 1.7 by 1.6, spiral with a bar, lenticular A, and it has a ring to it. 206 million light years distant. Rings are my next favorite kinds of galaxies after Aegeans. This at right ascension, 4 hours, 54 minutes, 38 seconds with a declination of plus 3 degrees, 16 minutes, 4 seconds. And if you can see the annularity and the frontier, typically it's about 4 magnitudes fainter than the collective cumulative magnitude of the galaxy, which would put this at about magnitude 16. Visual. NGC 1692 is a galaxy in Eridanus. Magnitude 13, 1.3 by 1.2 arc minute, lenticular, spiral, 473 million light years distant. That makes it bigger or smaller, the same size as Messier 31. You go figure. RA is 455.23 with a declination of minus 20.34.16. And out. NGC 1694 is another galaxy in Eridanus, right in the middle of the field. Magnitude 15, but don't let that scare you off. It's probably magnitude 14. It's 1.2 by 0.7 arc minutes, spiral with a ring. Now, it's a little too small to be able to make out any kind of angularity, certainly at 75x. I'm not seeing it, but maybe a few more passes will. It's 167 million light years distant, RA 45516, with a declination of -4 degrees, 39 minutes, and 11 seconds. Boy, the stars are looking a little bloated there. Final study in the 1650 to 1699 series, and it does turn out to be NGC 1699. Galaxy in Eridanus, magnitude 15, photometric. It's a spiral with a lowercase b, so probably 14.3 visual if it holds. 174 million light years distant, RA 45659, with a declination of -4 degrees, 45 minutes and 24 seconds. No, we did not get to hour 5 tonight, but I'll bet the next night out we do. Not a bad view of NGC 1699. Our final view for the evening is one that those who are familiar with the Messier catalog should be able to well identify. It's got two bright stars in the core, and it has a dark band which basically terminates what I would describe as reflective luminosity. I always think of the two stars as being eyes. And I always think of this as being the Casper, the friendly ghost nebula in Orion. And that particular nebulosity is Messier 78. It's in Orion, magnitude 8.0, 8 by 6 arc minutes, which means it's got an average surface brightness of about 12.5. 1,600 light years distant, like just about everything in Orion that's nebulous. RA is 54645, with a declination almost perfectly on the celestial equator of 0 degrees, 4 minutes and 45 seconds. That is a very nice view. But how about, we're seeing all kind of texture. How about if we increase the exposure time? Okay, we've now had 3 stacks of 30 seconds each of our Messier 78, the Casper, the friendly ghost. It's even got a smile on its face. Reflective nebulosity in Orion. Now, what you may not ever see in smaller scopes is this fainter nebulosity to the north and to the east. I'm sure it has its own NGC designation. There's also this outcropping of nebulosity swinging to the south and to the west, as well as to the north and northwest here. So, with that, I am going to say, and you can expect it, Carpe Noctem.